skipped, and for even one we popped one X to check that they lie. Number of ones lies exactly for twice number of this thing. So basically stack we are using for remembering something sort of how many zeros were there before we start checking for ones. Similarly, here in this case, for what purpose we will use stack? We have string shown like this: a b raised to power n, language says this, followed by a, then c, then a, followed by b n, and then a, where n is greater than or equal to 0. That means n could be epsilon also, n could be 0 also. We may have b's or we may not have b's also. That's the case. If we have b's, we can represent it as like as many number of times b's are available, those many times that will be the value of n. But if we don't have b, our string will become a c a, isn't it? This will be the case when n equals to 0. Otherwise, for n greater than 0, we have this case. These two things we need to check. And do we have same number of b's available here as well as here? For that purpose, we'll use stack just to count that how many times b we had earlier to going for ACA, which is nothing but the middle symbol. Okay, so let's check. We use stack only for checking how many b's are available, and we'll have simple state transition for A, C, A. Is this clear? So
Yes, sir, it is clear.
let's start with first is Q0. What does it says? Our input is single A, right? Followed by B. So A initially on the stack top, what we will have? We'll have Z0, right? This A we doesn't matter whether we count it or not count, because we know that there exists fixed number of A's here, like one A here, one A here, followed by single A, single C, single A. We can do multiple transitions for this simply, and we simply have twin closure for this B. We'll say A comma Z0, keep Z0 as it is. It indirectly means that we have skipped A. We have not performed any operation on stack. Then as soon as we get B, what we are doing? B comma Z0. Let's say push capital B on Z0. If we have just one B. If we have more number of B's, what will happen? We'll get another B, but at that time stack top would be capital B. So B on B. This will continue, right? When this is continuing, what is happening? When this is continuing, we will have n number of times this whole thing getting repeated. That is, for first B this, for n minus 1 number of B's, will go for this rule to be applicable, which will be followed by ACA. That means when on the stacked up we have capital B, when on the stacked up we have capital B, in that case, we will have A followed by C followed by A. Okay, let's write down that scenario. A in the input, and on the stack top, capital B, which we had pushed for small b's. Okay, now this A, C, A doesn't have anything to do with how many number of times b's were there. We'll keep stack top as it is, and this stack top's capital B will use for counting these raised b's which are available after A, C, A. Okay, so this is Q2 for A, followed by C. Also we will not do anything for on stack, followed by A on B, B kept as it is. Q4. Now here after A, C, A, we will get B's if any available. So for those B's, we need to pop one capital B from the stack. So small b and capital B. On the stack top, we have if you have capital B, and in input if you have B, in that case only what we will do is we'll simply pop this B. This will continue for all the B's which we have pushed here, capital B's which we have pushed here. And if we have same number of B's here as well as here, this whole process will end in the case when we get A as an input and Z0 as the stack top. Okay. A as an input and Z0 as the stack top. If this is the situation, in that case, we'll go for state Q5, wherein this Z0 will keep as it is. Okay. And according to the language, this A should be the last symbol. After that, we must have epsilon. So epsilon Z0, keep Z0 at is and go for final state. So this is the case when we have B is available with us. Okay. Now what if n equals to 0? If n equals to 0, after this second A, sorry, after this first A, we will not have B. Rather, we'll directly have this A. Correct? What does it mean? That we will not push anything onto stack because B's are not available. On stack top, we'll have Z0 only. So when we are getting A as an input, this A as an input, when B's are not available, that is n equals to 0, we will have A followed by Z0. Z0 kept as it is. Q6 followed by this C we will get C comma Z0 kept Z0 as it is. Q7. Last after this C we will get this A, and this A would be followed by this last A, right? This last A. For this last A we have already taken care. We have shown transition from Q4 to Q5. So we can directly connect from here to this case like this, wherein we have A which is coming after this C, that is A, and on the stacked up we have Z0. So ultimately it is this the case. Have you understood the process for language number 2?
Yes, sir.
Great. This is PDA. How to write 7-tuple definition for this? What is our capital Q? Capital Q is finite set of states. How many states do we have here? Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, and Qf. These are the states. Summation. Input symbol is what? A, C, and B. These are the input symbols. Finite set of input symbols. Tau is what? We are just using one stack top, B, apart from Z0. So capital B, Z0, this becomes our tau. Delta is similar to the previous example. That is, delta is this transition function whose mapping is Q cross summation cross tau gives Q cross tau star. Q summation tau delta, Q0 as initial state, Z0 as the bottom of stack indicator, and what? F is finite set of final states We have just one final state here, QF. Special stack symbol, initial state. Okay. Should we take more examples?
Yes, sir.